Great. All looks good here. Hello. Welcome. Good morning. We've made it. We're at the last day. Some of us are a little less awake than others. Thank you all for being here. My name's Scott Blake. You can find me on Slack, Twitter, GitHub, pretty much everywhere as mscottblake. A couple of you guys have asked me this week, so the M is my first initial. Doesn't stand for any company or anything like that. So anyway, though, we're here to talk about processing webhooks. We're going to do that using AWS to kind of cut costs and things like that. We'll use Terraform to deploy it, and I hope that you guys find some value in that. This QR code will take you to the GitHub where all of my slides and code, the links are available in the slides. I hope they're clickable. I forgot to check that last night. And I also put this link into the shared notes already so that you guys had it easier. I will post it again at the end, so don't worry if you don't get it up pulled now, but I would recommend it. I've got some slides at the end that I'm not 100% sure are gonna be readable enough from the back here. So I'm gonna leave this up here for a second. The main goal of this talk is to expose y'all to using cloud services to listen for and act on webhooks, webhook events, sorry. Using cloud services can be way cheaper, and using a tool like Terraform can make that process repeatable. And once you get it all working, you have that code. You can use that same code to spin up other services and other projects faster, and again, more reliably, repeatably, things like that. There's a lot of value in being able to do the same thing over and over again. So we'll start with some level setting. We're going to make sure that everybody knows what I'm talking about. We'll get into some Terraform and AWS, and then lastly, we'll walk through a code example that actually builds it all. And my hope is that that code can be some boilerplate for you to at least get 80% of the way there with your own projects. I do, however, want to note that this is kind of conceptual, right? These concepts don't just apply to Terraform and AWS. You can use other cloud services. You can use other configuration tools. I just find it easiest that when I present concepts like this, to showcase one approach. It helps to really drill into it. But I do want you guys to keep in mind that there are definitely other ways to accomplish these things. So, like I said, let's start with some level setting. What is a webhook? In its most basic sense, a webhook is a notification that fires when an event occurs. Some real-world examples of that can be, notifying an ordering system that a payment's completed, so that the order can be shipped, as an example. You can configure your doorbell to flash the lights whenever it rings. You can send a text if your data center gets too hot. We're all event-driven. How about sending a Slack notification when the computer enrolls into your NVM? The list of this is really endless. It's just your imagination. What can you come up with that's event-driven? APIs are, whenever you call them. These are when something happens. So I guess how are they configured? And that really depends on the vendor. In most cases, the vendor will provide an interface. It lists each available webhook, and then it gives you the ability to add a receiver. Now that's, in other words, that would be usually a web form that lets you put in a website address. And that would be where you want your data to be sent. As an example, on this site, you have to select which webhook you want to configure, and then you get this screen. And then this screen is where it asks you where you want to send and how you want to send your messages. Similarly, on this site, you enter the receiver, and then you select which webhooks you want it to attach to, right? So you can have multiple places Multiple things go to the same actual processor. If you look at 100 different sites, you're going to have 100 different implementations of this same kind of concept. But most of them have these same components. You decide on which webhook you want to configure and where you want to send your data to. There's not a whole lot else to it. So the question is, who here has seen a webhook configuration interface like this in one of the products they manage? That's a good bit of hands. How many of you have configured one with that? All right, that's pretty good too. I hope that you guys learned something. And for those that didn't raise their hands, I hope that you actually, hope this gets you started being able to. All right, let's get back to these slides here. So when a message is sent, what does that message look like? Again, that kind of depends on the vendor, right? Most webhooks will format their data with JSON. But I have seen other things. I have seen some in XML. I've seen some that are just URL encoded strings. That vendor documentation should describe what you're supposed to expect. And most, you can kind of bet on that. For example, this is a Jamf Pro. Which one is this? So this one gets sent whenever a message is, so whenever a remote command is sent within Jamf Pro to a computer or a mobile device. They have 22 in total. The documentation here shows what message you should expect from all 22 of them. But I think we can all agree that not every vendor does documentation great. It's just not very good, right? Some of them. Sometimes you just need to see real data to understand what's going on in those situations. I found this site. You can use this site if your message data is not confidential. I would not recommend it with confidential data because it is somebody else's website. But this allows you to read your messages in real time. When you go to this site, it just gives you a receiver address that you can use in your webhook configuration, and it sends it to this site. You then get the data out of it. If you do have confidential data, it's an open source website. You can spin up your own. It can be installed with Docker, Kubernetes, or any really PHP 7 web server. This stuff isn't really required, but it is a tool in your toolbox, right? It can help you with visibility into the process if you have any issues with it. If you have to troubleshoot an issue, sometimes, like I said, just you need to see what's actually going on to really get a handle on why it's not working the way you expect it to. The obvious next question is, what do I do with that info? To process your data, you'll need some sort of web server to listen to events, just like that last one. Validate and accept the message payload, and then you perform your desired action. The unfortunate thing is that you have to be listening all the time. So an always-on web server can cost hundreds or thousands of dollars a year, especially when you account for the maintenance cost and then the time investment it takes to manage those. And to me, that's where Terraform and AWS can come into play. So Terraform is an infrastructure as code tool. It lets you build, change, and version your resources in a repeatable way, like I said earlier. It works with both cloud services and on-prem servers. You just have to have a provider that does it. AWS, however, is a cloud services provider. And it contains over 200 services. We're not going to get into, not even scratch that surface. But again, like I said earlier, I want to reiterate that there's other tools that you can do this stuff with. If you're comfortable with another infrastructure as code tooling, use it. If you're comfortable, or if your organization uses a different cloud provider, use that instead. Just use this as ideas if that's the case. So let's talk about Terraform for a few minutes. Let's walk through some of the basic concepts. There are several different elements in Terraform definition. First, we have resources. Now, these are the code blocks that you'll use to define the things that you want to control in this configuration. So if you define a resource and it doesn't exist in the world, it will create it. If it exists in the world, it will modify it. If you delete it from your configuration, it will remove it from the real world. Those are resources. Data sources are used to pull pre-existing resources, so to pull the data from them. For example, if you have another script that might create a secret. Your current project, maybe you don't want to manage that secret, you just want to get the secret value. So things like that, that's where data sources come into play. So modules act as a container for those things. For both resources and data sources, you kind of put them all together into a module. They're really used as a way to package and reuse configurations. You can create your own modules. There's others that are out there on the internet. I find them a lot easier to use, and we'll get into a little bit more of that later on. And then there's a whole lot more than this, but the last one I have listed here are input variables. These you can kind of think of like script parameters. It's a way for you to customize your configuration without changing the core of the source code. Common use case for that would be defining the differences between a dev and a prod environment. You may have different AWS environments. You may have different resources that you want to talk to. So you'd put those into variables. So let's dig into a resource a little bit. Like I said, these are things that you want to control in your configuration. So I'm going to use an S3 bucket as an example as we go forward. Does everybody understand what an S3 bucket is? I kind of figure most people do. All right. So in this example, we're defining that we want an AWS S3 bucket with the name of my test bucket. That's as simple as a configuration has to be. Terraform will create this bucket. If it doesn't already exist, it'll modify it or delete it as it needs to match what's in this definition. So if you modify a bucket by hand after it's been created by Terraform, then you run it again, it's going to erase those changes that you've made by hand, and it's going to apply these configurations again. So keep that stuff in mind when you're doing this thing. Generally, once you create something within Terraform, you probably want to keep maintaining it within that Terraform configuration. If you need to reference this resource from another object, you'll use what's called dot notation. And if you watch this, it will show you exactly how those work. The actual resource type goes in first. The name you gave it comes in second. And then it's the attribute that you want to use. For instance, the AWS S3 bucket resource has this list of values that are available to you. All you have to do is create the resource. You don't have to do anything else. These values are then accessible to you elsewhere in your code. You don't have to do anything special to get them. The AWS provider has this stuff pretty well documented for every single AWS resource that they maintain. This is the website for it. You'll notice that this is the specific one for the S3 bucket. You can cut that down a little bit, and you'll get all the other resources that you want out of it. All right, so if we go back to our example where we define that S3 bucket, we can reference these attributes in other resources within the configuration. So this would then also enable object versioning. So if you replace an object within the bucket, it'll version it, things like that. As you can see here, we're using that ID to reference the bucket. It's that same dot notation. That first resource up at the top is the bucket name and things like that. It's just an example of how you can use one resource and reference it in another. Moving on to data sources. These are used to pull data from pre-existing resources, like I said. It's essentially read-only data. So here we are with an S3 bucket again. In this example, we want to reference a bucket that already exists. We don't want to maintain it in our code here. It could be created by another script, by another team, or even created manually, and we just don't want to risk changing any of its configurations. We're not assuming ownership of it with this code. And when we define it as a data source, we're not modifying its value. Like I said, it's all read-only, and I want to make sure that that's stressed. Referring to them is very similar to referring to resources. We just have data in the front. The type and name are the same. Yep. It's all documented just like before. Here's the same example where we're enabling object versioning. The difference in this example is that the bucket already exists, and we don't want to manage its creation in this script. We only want to change its configuration. Is this making some sense? Okay. Because now we're on to modules. And this is kind of, to me, where it kind of gets interesting. These act as containers for multiple resources and data types. Usually they're like data. So like I said, they're used as a way to package and reuse those configurations. Here's an example of creating that same S3 bucket. We give it the same name. We do have to give it a source for where we want the module to come from, where the module source is, so that it can pull that. But other than that, it's very much the same. For this example, it might not make a lot of sense to use a module because it's just one or two resources. But as you get more and more complex, the modules make more sense. So again, referring to modules in dot notation is pretty much exactly like resource and data types. But instead of putting data in front of them, you do module. But because they don't have a resource type, it's just module and then the name that you give it. And then the last bit is the module output. And when the module is created, it has defined inputs, it has defined outputs. Each module should have that documented on the Terraform registry site. If it's something that you create, I'd highly recommend you document that as well so that you know what options you have when you're using this module elsewhere. So if we go back to our example again, where we define that S3 bucket, you can see where it starts to make sense to use a module when you add the versioning, like we did in the previous examples. So if you think back, this required two resources, or a data source and resource, something along those lines. Now we're defining it in a single place. The structure of how we do that is a little different. Again, that's going to vary by the module creator as well. Again, that stuff should be documented pretty well. If, in this case, AWS is maintaining it. So if they change something within the configuration and you have to change how you do versioning in this case, they're going to change the module source as well. So really, all you have to do is change your version. You don't really have to change how and learn how they made those changes and read into their docs real deep. This can be really useful for those types of things, especially when they make major changes. So like AWS 4 to 5 had some breaking changes in it, and using the modules helped mitigate some of that. And it definitely made it easier to update. Using modules also makes it easier to add new configurations later on down the road. Because again, the module handles the logic for whether or not these features are enabled. For this demo though, the specifics of this stuff don't really matter. I just wanted to show you how you can stack multiple settings together in a single module. If we were using individual resources, this would probably be 4, I think. So moving on to variables, like I said earlier, you can think of these like script parameters. They allow you to customize the configuration without needing to change the code. Defining them looks pretty simple. It looks like most other scripting languages. There's a couple examples of the values being applied to variables, and it's pretty straightforward. These values will go into special files that I will describe a little bit later. But like I said, it's pretty straightforward in how to define them. So again, let's go back to that example module, and let's use variables instead. You'll note that the reference to these elements are var.variableName. You can, nope. Yeah, that is what I was going to next. So at this point, I've shown different ways to reference these variables. They're all listed here with the same examples that I used. But there's another way to note them as well. If they're part of a string, what you do is you wrap them in curly braces, you put a $sign in front of them, and they can go inside that string wherever you want. If you have more than one value you want to put it in the string, it's definitely possible to do that. This is an example of where you might want to do something like that. Now, if you do find yourself doing this a lot, referencing that same, string multiple times, you can assign that to what they call a locals tag. And here, I'll show you what it looks like when you're in use too. You reference that with a local dot variable name instead of var dot. There are a ton of possibilities with the local tag. I don't even want to get into it. But what I will say is the general gist is that any expression that you can make within Terraform, you can create that as a local, and it basically gives you a name you can use to reference it. So it can simplify your code down for things that are repeated around. So that was a pretty high overview of the various Terraform elements. Before I move on, again, is this sort of making sense to you? Okay. So we're going to move on to our commands that we use to actually run Terraform. We're going to start with Terraform init. This is the first thing you do inside of a folder that contains Terraform files. What this is really doing is it's setting up your state. That it has to hold the state of these resources so that it knows what needs to change and things like that. So this sets up that environment. Terraform validate, make sure that you don't have syntax errors. Highly recommend you run this because it can save you a lot of headaches in the long run. Terraform plan it can be run separate. It can be run as part of apply. I would recommend separating it. The best part about this is that you can output it as a file. By default, it outputs just straight to the screen. If you put it into a file, you can then use it in the Terraform apply stage. This is what actually makes the changes to your infrastructure. So use this tool with caution. It can do some serious things. Just like Terraform destroy, obviously, just wipes everything out that you've configured. So the first thing you need to do with any Terraform project is initialize the directory. To do that, you run Terraform init inside that Terraform directory, like I said. This is the one where your actual files live. So in this example, I would cd into the Terraform directory and then run Terraform init. You'll notice in this example, I have an extra flag. The variables that you can use to define where it's stored can be put into a variable file, just like I was listing earlier. That file looks like this in my example. There's nothing to it really, but it does require a few keys to make it work. In this situation, I'm storing that stuff in the cloud as well. I'm not storing it locally on the machine that's running it. And that way, multiple people can maintain this Terraform, and the state gets stored in the cloud. So we define it with a bucket, a region. We do have to have a state lock file as well. That gets stored in a DynamoDB table. But again, this stuff is all documented as well. If you want to do something else, you don't want it stored in the cloud. The init function is pretty well documented as well. Terraform validate is nothing special. This just validates the configuration files in your directory. Again, really all of these Terraform files are run in that Terraform directory, not in the root of it. This one doesn't take any other parameters. When you run it, it'll either tell you that your configuration is valid or it will list out all of your syntax errors. Plan, like I said, creates that execution plan. It will do essentially a dry run of what do we need to change to make this match up. By default, it just prints to the screen, like I mentioned. But you can change that to put it out into a file just with the -out parameter. Now, we can take things a little bit further. You can also add your variable files to this command with var file parameter. Personally, I like to separate my variables into two categories. Excuse me. If it's going to be the same in every environment, I just use config Terraform. If it's going to be different in every environment, I make a folder for each environment, and I also have a file in there. You don't have to. I find it a best practice because I don't have to have the same variables replicated around. If I need to make a change, I don't have to change it in 3 different places in this example. I just change it into one. Again, here's some actual data that's in this sample. You'll notice that the domain is different for each environment, or is the same for each environment, but the subdomain is the same. Sorry, I'm messing it all up. And that's an example of how you can use, different variable files to maintain things and others that are different for each. That's why in the example earlier, I had subdomain.domain and not one big string, because it helps me if I need to change the root domain, it's changed in one location. The apply command, like I said, makes the actual changes. It's very powerful as it can create and delete cloud services. If you run this command as is, just like this, it will run Terraform plan as part of it. I would not necessarily recommend doing that, though. If you run plan on your own and then you run apply later without using the plan file that you create, things could literally change in that time, and you could be applying changes where something changed externally that you didn't even know happened. So that's why I suggest using that plan file, because that one snapshot in time is what gets applied. We're not planning again. Again, if you're running these in an automated script or something like that, CI environment, GitHub Actions, something along those lines, you're going to want to disable the input prompts. You don't want it asking you things and pausing your runs. This will, however, assume that all of your necessary values are either provided by your configuration or your command line, variable file, something along those lines. If it cannot find a value, it will error. If it's not present, it won't ask you. So that's the caveat for doing something like that. Terraform destroy, like I said, just wipes everything out. This, however, is a convenience function. What it's actually doing is doing a Terraform apply -destroy. So the cool thing here is that it takes all of the same parameters that apply does, all of the same variables and things like that, except the plan file. That's the only difference. So similarly, if you want to simulate destroying it, but you don't want to actually destroy it, you run Terraform plan -destroy. And it will tell you what changes are made. Pretty sure you can also add an output file so that you have a file for this output, but I didn't actually test that. So moving on. Now that we know a little bit about how Terraform works, how we interact with it, things like that, we'll use that to build services in AWS. There are hundreds of services available. We'll end up creating a dozen or two with this thing, but there's really 2 main services that we're going to focus on today. And that's API Gateway and Lambda. So don't worry about being able to read this. This is straight from their marketing. API Gateway allows us to expose a web address to the internet, and it allows you to route traffic to another service. That's really all it is in its basic sense. It's fully managed, which means we don't have to run servers. We don't have to manage uptime or anything like that. We are only charged based on the number of hits, number of messages that you send through it. The current cost of that is $1 per million hits per month. So pretty cheap. If you're eligible for the free tier, that is the free tier. It's $1 million or 1 million hits per month, not $1 million. So like, if you're trying to play with this stuff and you want to get interested, you're interested and you want to start playing with it, spin it up. Like, you're not going to hit 1 million in a month unless something really, really haywire, goes off the rails. Lambda is kind of similar. It's event-driven compute service. It lets you run code in the cloud without having to manage the servers behind it. And similar to API Gateway, you're only paying for the runtime of that code. So if it takes 30 seconds, you're paying for 30 seconds of runtime. It's also part of the free tier, and the limits are pretty high. Like, you're probably not going to hit it just by playing around with this stuff. Using these two services, we can create web applications that are always listening, but we're only paying per message. So it can be extremely cost-effective depending on what you're trying to do. It's not the end-all be-all fix. There are some situations where it's a huge amount of messages where listening all the time may be the cheaper option, but likely not. I have a project like this. It's been running since mid-February. It has cost 9 cents in total. It replaced a service that cost $1,000 a year. There are Terraform modules with more examples and use cases for both of these services at these links. I'm going to go through one of them, but these links will give you some more information if what you're wanting to do is a little different, something along those lines. So let's switch over to text editor and take a look at an example that puts it all together. And this is where I'm really hoping this stuff is readable to you guys. Seems okay in the back? All right, good. I don't want to go through all of these files granularly, but I do want to call out some important parts of these scripts. The Terraform block that's here, this is where you set your general Terraform settings. This is just another resource type, essentially. In this block, I'm defining that the state and other backend components are stored in S3. This is where that configuration goes, and this is why that variable file was needed earlier that we can define. You can put that stuff in this block, this backend S3 block. The bucket, the region, the DynamoDB table, all that stuff can go in this block. But then it's the same no matter what. So if you have different environments, you're going to clobber over your state. All right. The required providers block allows us to set limits on those provider versions. I haven't really talked about providers, but a provider is something that a company will give that defines all of the resources. AWS is one. We use Cloudflare for our DNS, so that's in this example. If you don't, I'm sorry. You can make these limits exact versions with an equal sign. You can make them greater than a version. If you use the tilde greater than, like I have here, you're essentially doing is saying that the last variable, the last set in it can change, but nothing else. So as an example, that Cloudflare version that is 391, it could be 392, 393, but not 3.10. Okay? Similarly, the AWS could be 422, 423, 490, but not 5. All right? So this is a way to limit and control your blast radius when external changes happen, breaking changes happen, things like that. The required version setting, this configures Terraform's constraints. So in this case, I want this code. I know it works with 1.2, has to be greater than that, right? These are the Terraform settings. Terraform version has to be 1.2 or higher. Now, you'll notice that I have 9 Terraform files in this configuration. I could have put it all into one single file. That works. I could put it into 20 files instead. That works. It just depends on how you want to organize them. This is all up to you. I like to keep each resource type separate as one of the requirements that I do. But you'll commonly find like this Terraform block included in what I'm calling the main.tf file, which is right here. The provider block is where you put the provider settings. These are similar to the Terraform block. And that's why you'll often see them put together. Like I said, I like to keep each type separate. That's just me. The Docker provider is used to create a Docker image of the Lambda with all of its dependencies, and that's really the crux of this demo. It needs a place to store those. So that's something that gets configured up front. So we're giving it an address, username and password, things like that. These were actually provided by the provider. I don't really actually know how they work. I just know that they do, as an example. So this is essentially creating ECR, and I'll get into what that is. It's an Elastic Container Repository within AWS. In order for the variables that I described earlier to actually work, you have to define every single variable that you're going to use. Similar to C, if you've ever used that as a programming language. You have to define every function that you're going to use before you actually use it. They're pretty straightforward. Not all of these things are required. You don't have to tell it it's a string. You don't have to give it a default. You can have just plain variable things. Again, I like to give descriptions, things like that. I find it a whole lot easier it kind of helps to self-document in this way. Now these are often split out into their own file in most configurations. And that's usually because there tends to be quite a few variables in things. And it can really clog up the rest of the files. What you might find, however, is a lot of people will put their data files or data resources in that as well, because they're not really actual resources. I like to separate them, because like I said, I like to have each different resource type in its own file at the very least. Mainly because I like to make sure that I don't get confused by things that I'm configuring and things that are read-only. Because oftentimes if a data element is right in the middle of a whole bunch of resources, you just assume that you're making changes to it when maybe you're not. For example, in this, we're getting information about a Cloudflare zone. But we don't want to configure it because this is the full domain. It's the main zone file for that domain and DNS. But what we do want to do is configure a subdomain. And we do that in the Cloudflare file that we have here. This creates a CNAME entry for that subdomain within Cloudflare. It points to the API gateway domain name that gets configured. You don't need to use Cloudflare. I want to reiterate that. We do. That's our DNS. So I happen to know this works. If you have another DNS service, they may have a provider for it. If they don't, there are a ton of resources about using AWS's DNS service, which is called Route 53. I didn't want to have to spin up Route 53 and test it just to make sure that this stuff works. I know this stuff works. So like I said, if you don't use it, I'm sorry. Up until this point, most of these files have just been some boilerplate Terraform. They're going to look different for every project, but they are going to be required in most cases. Maybe not quite all. But this, the API gateway file, is kind of where we start to get into the main configuration for this project. If you remember back a few slides, I explained that API gateway, it allows us to expose a web address and then route it to another service. We do that right here. This defines the base URL of the API gateway, and then this defines the path for each endpoint. You can define your integration to listen via post, via get, or any. Those are your three options. So if your code doesn't care if it's get or post, use any. Otherwise, select one of those two. We then direct that traffic to the Lambda function. Now, you can have as many endpoints as you want in API Gateway. And the code that I've set up here allows you to have multiple Lambda files, multiple Lambda functions. All you really have to do is duplicate the Lambda file. I'll get into that in a little bit, but what you basically do is you just have another block within this integration section. I'm listening on this path, send it to this other location. Then lastly, as part of this, we're storing our access log somewhere. So we're not actually losing telemetry by having this in the cloud. So every time somebody hits one of these resources, it gets logged, and this is where that stuff gets set up. In this situation, we're creating a new log group within CloudWatch. Onto that Lambda function. Like I said, in our case, the service API gateway is sending requests to a Lambda function. Like that's the flow. I want to make sure I repeat that a few times. This file handles the creation of the function. There, like I said, are many tutorials for creating Lambda functions, but very few of them handle Python dependencies. And even less than that, do that in Terraform. So I wanted to make sure that even though that complicates my example a little bit, as Mac admins, we're usually taking webhooks and sending them to another service, such as Slack, such as Jira, some other SaaS product to do something else with it. Usually that requires a Python SDK or something like that, where we're bringing in dependencies. So this was important to me to have in this demo. All right, so let's start with the Lambda, Lambda function creation. This is handled with Docker, and it's using the Docker build module. Like I said earlier, the ECR stuff that was in the provider definition, what that is essentially doing is it's creating an Elastic Container Registry. That was what it was called. These settings define where and how those Docker containers are stored. So in the provider, we're configuring how to connect to it. This is configuring where within there do we store these files. And then this is really the settings for the Docker container as a whole. The source path is the root directory for the Lambda function code. It's in reference to this file. Within that, the Docker file path is looking for the Docker file that creates the Docker image. It's what will configure the container. And then lastly, the platform setting is what allows to define the architecture. You want to make sure that your architecture is consistent throughout. So in this case, I'm using Intel, AMD 64. Let's take a break from Terraform for a second, and we're going to look at the actual Lambda function. First up is our Docker file. There's nothing special about this. If you're familiar with Docker, you know what a Docker file is. There's nothing at all that should be confusing about this. The base image here is configured or maintained by AWS. It's the exact same environment that a normal Lambda function is going to use. This is what they use within their Lambdas. In this case, we're using Python 3.10, but again, that's configurable. 3.11, I believe, was just released last week. They do lag back a little bit from what Python releases. So make sure that you keep that in mind when you're writing your stuff as well. I would highly recommend that you use one of these base images, just because this is what the Lambda would be running anyway. So it's more similar to what a normal Lambda is going to be. We're then copying a couple files into the Docker container, and then we're running a pip install. Using the dot here, we're putting them in the current working directory path, which should just be root in most cases. And then lastly, when we run the Lambda code, what we're really doing with this call is we're telling it to call the Lambda handler function within the index.py file. And you can see that on the sidebar, there's an index.py. You want to make sure that if your code is structured differently and your starting point is defined in here, that it's the same. The next file is a requirements file. And again, this is nothing special. I feel like most everyone has probably seen one of these files. It's where you define the dependencies of your Python code and what modules will need to be installed. So there's nothing special about this file. The last file in this sample Lambda function is the actual Python code. In my sample, there's nothing to it, but that could be different for you. This can be as complex as you want it to be. The only thing that you got to make sure of is that the function that you're calling within your Docker file matches the function in the code where you want your thing to start. If it's main, you'd put index.main. If the file is named something different, it's something different.main, etc. All right, so we're going to go back to that Lambda function Terraform code again. So far, we've built the container that includes our code and all of its dependencies. But we haven't added that to the Lambda service yet. This is just local, essentially. And that's where this module comes into play. So this section here was basically saying, don't create the package. We've already done that. But we do want to upload it. So we want to publish that. And it will push it to AWS. But to do so, we need to give it a path where we stored that Docker container. So this is a reference to the module, for that Docker build module that's listed down below. The allowed trigger setting is something that's really useful. It's not required, but what this does is it limits who can actually call this Lambda function. Your security folks will love you for putting this in here. What this is doing is saying the API gateway is the only thing that can call this function, period. So, like I said, security is going to love you for it. In my screenshot, I've got a little typo here on line 24 where it says allow API gateway post enroll. I missed a copy paste. That should be post sample. But it can be anything you want it to be. That's just the name, the label that we give it within AWS. This will still work, even if it's named whatever. It's just going to have an odd name if you don't change it. Now we're almost done with Lambda function, I promise. If your code needs to access some external resources, like Slack, like Jira, like your MDM, you're going to need some sort of egress through networking. You basically have to open up the ports. This rule, your security folks may not like as much. This one opens it up to the entire internet. But again, if you're limiting what can run the function, maybe this isn't as big of a deal for them. And you don't have to be as specific, maybe. If you do need to set that egress, what I didn't show earlier is that you can specify a list of security groups that get applied to this container. So that last module was a security group module. You give it the ID, and it adds it. And that's how you apply that network rule to this function. All right, last file is a bunch of outputs. You may want some of these. You may want all of them. There are a lot in this example. But I wanted to show really that we're not losing any telemetry. We have all sorts of data on this stuff. Every single time that Terraform apply runs, for sure, every one of these outputs gets spit out into the screen. You can, forward that to a file if you want for an artifact in your CI build or something along those lines. This is where you'll find the full web address for your API gateway, things like that. They can be very helpful. It's very useful for troubleshooting It can also be very noisy. So with that, we still have about 26 minutes. I can take lots of questions. I know I kind of went through some of this stuff a little bit fast. I apologize for that. I'm a little nervous for being up here. But like I said, if anybody has any questions, fire them away. Yeah.
Is this thing on?
Yeah.
I'm curious about the var files that you use.
Okay.
In the past, I've used Terraform workspaces or been forced to use them. I'm curious what your thoughts are on workspaces versus var files. Like, why is one either easier than the other?
I've used workspaces a very little bit, so I'm not super prepared to answer that. But what I will say is, workspaces, I think, work better if you have one environment, one AWS account with multiple things in it that you want to configure. Whereas var files may be better if you have different AWS accounts. Please don't quote me on that. Just from my brief experience with workspaces, I read up on them. I was like, oh, that's cool. But in practicality, I haven't really used them. And I think that is based on my environment. So your mileage may vary on that one. All right.
Are you doing something to secure your API gateway so that only your services can talk to it? Or are you just open public access?
I am currently not right now with this one. But it is possible. I don't really know how because I haven't done it yet, right?
Okay.
But like I said, I've read some things. I know that it's possible. I just haven't played with those settings. You can do different auth configurations. API Gateway is a very, very powerful service. This only scratches the surface of that. So if you have something that you need to secure, I bet it can do it.
The only time I've ever done it is with a public one as well, but I'm always concerned that someone's going to like find it and slam it with a bunch of requests, and then I'm going to get a giant bill or something like that. So are you doing anything to like set cost limits in AWS so that you don't get hit with a giant bill all of a sudden?
I'm not. Largely because you have to really slam it. And I'm going to notice in my Slack before that happens.
Hopefully, yeah.
I'm going to notice in my Slack. I'll say that. The example that I used is from an MDM enrollment command. That's what I did. So when a computer enrolls in the MDM, it fires off a variation of this code. I stripped a lot of stuff out of it. It does some things and then sends me a notification in Slack. I am a little concerned that that's open. And that is something that is on the backlog for us to deal with. But it was more of we need to change this service out. It's costing too much money. Mm. The old service didn't do that either. So it was kind of a feature parity change. We can add to it later and secure it better. But right now we're not going any farther than what the existing code was. So that's where we were with that. And that's why I haven't gotten into that. I am a little bit concerned about that. But frankly, it's been 9 cents in 4 months, something along those lines.
Yeah.
Even if it's hit a whole bunch of times, it's not going to break the bank in my organization. Oh, almost.
How does that last question differ from the allowed triggers that you covered that seem to kind of provide that protection?
So the allowed triggers is on the Lambda function itself, the API gateway. So the allowed triggers is basically saying the only thing that can call this function is API gateway. But the API gateway doesn't really have any protections on it.
Thank you.
Yep. Like I said, if that's something that is a concern for you, I'm sure that it can do it, and it's probably not that difficult. maybe a day worth of trial and error. I figure any of us would be able to get it. Any other questions?
Are you storing your secrets in AWS?
Some of them, yes. So what I'll say is AWS Secrets Manager is a great tool. It's very well supported in Terraform. You can have a resource that creates and sets a value to some random string, and then another thing that uses that value in another config tool somewhere. And you never have to know what that value is. It can automatically rotate, things like that. And that's very easy to add into something like this. It's just another, file, secrets.tf, or you throw it into something else, and it's really just one or two resources.
Anybody else?
Going once, going twice. All right, we got one over here.
Could you talk about, from a high level, like what problems you've solved using this workflow? And do you have any ideas of future problems you'd like to solve using it?
I'd say the biggest thing is we don't have a reliance on on-prem machines to run things. We don't have servers that are always running. Even though it's a physical server and doesn't cost a whole lot of power, maybe, there's time investment in making sure it stays up to date. There's downtime when you have to run updates, things like that. Those are problems that we've solved. We don't have any downtime with this, basically. Lambda and API Gateway, because they're fully managed services, have enormous uptimes, way better than any of what of us can do. So that's a big one, right? It's also cheaper. I cannot stress that enough. This workflow is super cheap, especially if you're not hitting it all that often. Even if you are, your biggest cost is probably your logs at that point, which if you've done anything in AWS, the logs aren't really all that bad. So that's, those are the two big ones right there. It's increased uptime. It's faster, oftentimes. And it's flexible, right? So this same boilerplate template can be used to spin up different things without a whole lot of development time again, which is another huge improvement long term. And it's hard to overstate that. It really is. So even if it's a bunch of small little things, those things can add up. You can structure your stuff to have one API gateway that farms out to lots and lots of different services, whatever you're trying to do. You can have a different API gateway for every different service you want. It's all flexible. So I think having that flexibility helps us a lot. I hope that answers you.
Yeah. How about from like a device management or like IT process perspective? Are there certain things that have been made easier using Terraform in these workflows?
Actually, yeah. So, we're a pretty DevOps heavy shop. Pretty much anything that goes into production needs an approval. It needs somebody to review the code. So having it in code helps a lot. It's a lot easier for us to get something into production without having to go and ask for an exception. Can I do this? So having that in Terraform allows us more flexibility, even though it has an extra burden of having somebody else look at it. That other set of eyes, though, is also something that's empowering, right? You're more confident in my code works. I've had somebody else look at it. They didn't see anything weird, that I'm doing something stupid, something along those lines. Terraform Validate helps with syntax errors, as an example. So I'm not pushing code out that's going to fail. So a lot of these tools just intrinsically help with some of that. So I love it.
So what are you using that notification in Slack for MDM enrollments to do? Like, does that kick off some sort of process, or is that just helpful to know what's happened?
The Slack notification is just to know that something happened. There's other things that it does too. We're a monkey shop, I'll say that. It creates the manifest for the device and then notifies us that it happened, right? So But you can do anything with it. Like I said, that Lambda function itself is just Python code. Your Python code can be super extravagant, do everything you need it to do under the sun, or it can be really, really isolated to do one thing. And that's up to the programmer, the developer, to actually do. So it's really up to what are your requirements for the project that you're working on. And the Terraform portion of that is the same. You're just spinning up a Lambda function, and then it does the rest. And the Terraform part of that is deploying the function. And I know that was a big chunk of this talk, was the Terraform itself, but that's largely because most Mac admins don't really have experience with that. So I want to kind of level set and get some people playing with that. But the rest of that is just stuff we're already doing.
I know I've set stuff up in AWS and then exported a CloudFormation template and then looked at it and I was like, oh my gosh, there's so just variables screwed everywhere, and it's very, very verbose.
Yeah, CloudFormation is it's a really great tool. It's AWS specific. I can't do Cloudflare stuff in it, as an example, right? So Terraform allows us a little more flexibility in what we're doing, but CloudFormation does that stuff too, if it fits into what you're trying to do, right?
Yeah, this looked way nicer than what I've experienced trying to use CloudFormation templates.
I've done a lot with CloudFormation templates. I talked at JNUC 2022 about them, using SAM, which is an extension of CloudFormation, but doing this same kind of stuff. So if this is that's something that interests you, go check that out. But Terraform is a little more object-oriented, I guess, ish, in how it approaches it. There's different resources and things like that, whereas CloudFormation is all just YAML. And it really, some people will say that Terraform's way more complex. Some will say CloudFormation is. And there's other tools too. So it really kind of depends on what you're used to, what you're familiar with, what you're trying to do. And that's why I said it a couple different times. This may not be the tool for you. Mm-hmm. But the concepts are still the same.
Yeah, I do really love YAML personally, but I also really liked what you showed with local variables and how you can basically not repeat yourself, and anytime you're doing something more than once, just make a local variable for it and reference it. And that makes it really easy to update later.
Yeah. And like I said, that locals tag is very powerful. And I could probably give a whole talk on it. I would have to do a bunch of research because I don't know half of what it can do. But yeah. And really, any of these services, Lambda's the same way. You can actually invoke Lambda from a URL. Your security probably won't like that. That's why I'm using API Gateway instead, because it's already a service for that. But there's other ways to do a lot of this stuff that I just showed. This is a way to do it, as Chris Daw said.
Anybody else?
Anyone over here? All right. Well, then I'm going to put this up again, just because, in case you didn't get it earlier. All right, see, no cameras. Thank you. Please leave some feedback if you like this. If you didn't like it, that's fine too. I want to know it. Please be honest. I won't take offense. With that, I will say thank you.